Let's go through the code number 416, partition equal subset sum. And for this question, it gives us an integer array. And trying to see whether this kind of integer array can be partitioned to two subsets so that each subset have the same sum. For example, 1, 5, 11, 5, we can partition to 1, 5, 5, and 11. Both subsets have the sum of 11. So for this question, let's get the sum first. If sum equals 0, and for int nums, sum plus equal none. And let's say first thing is that if this sum multiply 2, I mean this sum is an odd number. Of course, we cannot separate it into two parts which have the same sum. So if this one is mod 2 equals 1, we just return false. Otherwise, we'll have int target equals sum divided by 2. So for this question is that we want to see whether we can from this array trying to see whether we select some number of integer, whether we can form a sum to be target. So we can use an boolean dp equals new boolean n and target plus 1. So what did this mean? dpij means for index from 0 to I, whether we can get some j, right? So we'll say dp 0 will be 2. That is for the first num 0, right? We can choose or not choose. If we not choose it, then we can get to the sum there, right? And then what we do is that for int I equals 1, I smaller than n, I plus plus 0, 4 j equals 0, j is smaller than target plus 1, j plus plus. So we have a case 1. That is we don't select nums I. Then dp I j equals dp I minus 1 j. And in case 2, right? Case 2 is that we select nums I. In order to select the nums I, we need to have a if j greater or equal to nums I. dp I j all equal dp I minus 1 j minus nums I. And in the end, we just return dp I minus 1 target, right? New we need to have this nums length n equals nums dot length. And J cannot find it. So this is 0, 1 backpack problem. And we know every dpij only depend on the row dpi minus 1j. So actually this kind of currently the time complexity will be n multiplied by target. And the space will also be n multiplied by target. But we can use a rolling array to specify the space complexity to be only O target. So we just multiply this by 2, right? Just as like what we did for like the unique path or falling path, those kind of questions. We did this before, right? So. And we return this. This kind of approach, the time complexity is still n multiplied by target, but the space complexity become O target. So we specified the space. We optimize the space, and actually for this kind of space optimization, we can get even better. We can have just a one-dimensional array to be Boolean target plus 1, and the reason is that for when we calculate this dpij, right? dpij, it only depends on dpi minus 1j and dpi minus 1j minus nums I. It depends on this two, right? So when we calculate to this number, we can iterate j every time. We can use just a one dimension. Every time we iterate, we just iterate j from target to 0, so that we go this direction. Because that is if we iterate j from 0 to target, right? And we calculate this dpj, the value changed. This number dpj minus this target will be a new number. But when we calculate, this one depend on dpij minus target nums in the previous row. In order that we still use the old number, the j, which the iterate from target to 0. So this one can be simplified to one-dimensional array for dp. So we can have dp0 to be true. And here we need to have j to be reverse direction, target, j equals target, and j greater or equal to 0, j minus minus. And we don't need to have this, don't need to have I anymore. We just return dp target. This case 1, case 2. Actually, we can even simplify to be j greater equals to nums I, and how this one to be just this, right? Okay, so this way we have the backpack DP for this question, and the time complexity is A multiplied by target, and the space complexity now we will be only O target. Let's recover one of the questions we did before. That is a unique path. And still remember for this question, when we did this before is that we have int dp equals new int m a, right? So we have dp 0 0 equals 1, and for int I equals 0 I smaller than m, I that is right. We still have dp the first will always be 1, right? We can have this, and I plus plus, and for int j equals 0 or 1, j is smaller than n. J, sorry. I have arrays till dp 0 to be 1, right? Something like that. And also we have for int I was 0. dpi 0 equals to 1, something like this. And then we have the dp ij equals I minus 1 j and plus I j minus 1. And for this question, last time we do simplified use the unify the rolling array, but actually for this question, every time this number is just coming from the top and the left, right? So we can also use a one-dimensional dp to to optimize this. But the value is coming from the new value here, right? So now what we iterate J should from the left to right, not from right to left, because we need a new value from the left. So for this kind of question, we can also optimize use one-dimensional array. So it is like this: dp equals new int n, and we know dp one will be dp zero will be one, right? And we just do for int I equals 0, I smaller than m, I plus plus, and for int j equals 1, j smaller than n, j plus plus. dp j will be will be it from the left and up, right? So it will be equals dp j. This is the previous row, right, in the up, and plus dp j minus 1, right? This is on the left. So we can also change this one to be one-dimensional, right? But because we need a new value from the left and an old value from the top, so we can write like this. So we just return dp n minus 1. So this of course, the rolling array, the space complexity is 2 multiplied by n is also O(n), but this one we can also optimize to just a one-dimensional array. Like, but the thing is that we need to try to see this value depend on which value is coming from top and the left. So we should iterate J from left to right. But for the 0, 1 backpack problem, the value is depend on the top one and an old left top one, right? Not from a new one from the left. So in order the value will not cover the previous one, we have to iterate the J from the right to left to optimize this. And there is some other questions, like there is another one called the minimum falling path. And for this question, the value dpij will depend on the top left, top, and top right. They have 3 directions. So for this kind of question, it's very hard for us to optimize to be one dimensional dp because have 3 values. It's hard. We don't know whether we iterate from left to right or right to left. Maybe it is possible to do it because we every time we iterate, we use a temp variable to store a previous value, but it will be kind of difficult. So for this kind of question, we depend on we cannot 3 values, right? Can be a left, top, and a right. So the basis situation for us is still using rolling array to divide by 2, right? That will get things simpler.